Looks like we're live. Right, we're live. I'll start in a few minutes. Actually left 4. Alright, there are not many things we need to cover for this review. If you have any question on the homework, that would be also nice, because the lab only have 18 questions. Right. So I haven't seen any question on the chat yet, but I'll just start with number 1. Right. So this is the Lagrange multipliers. The first two problems will take a lot of space, so we have to divide in half of the page here. Right. First, in order to find, in this case, it is asked to find the maximum, the minimum. Not really important because we do not check them. It will be too much to check the problem for the maximum or the minimum. Just find a point, really. Right. The first step is we'll have the function and we have the equation, which is the constraint. So we'll change that to bring everything on one side. And that will be g of xy. Right. After that, we will form the function for Lagrange multipliers. So the function will be a function of xy and then the lambda, which is the original function to be maximized or minimized, and then minus lambda times the constraint g of xy. Right. So we do that. G of xy right, and then we multiply it out. Right. And so that is the function. Now all we need to do is take partial derivative with respect to x, y, z, x, y, and lambda, and make them equal to 0. So first, by the way, on the test, let me see where was the requirement. So yeah, so in the test there will be just question just to set up the function of x, y, and lambda. So that will be the first part of the problem. If they only ask you to set up the function, that's all we do. Right. Now to find the point from here, I will take derivative with respect to x, y, and then lambda. Derivative with respect to x will be 2x minus lambda. Yeah, x, those are variable of x, and we just have that. The second derivative with respect to y, so derivative with respect to y will be for those two that has those two have y, so we have 2y minus lambda, and then derivative with respect to lambda will be those three terms, negative x negative y, and plus 1. Right. And we make them equal to 0. And then we solve for it. Right. I label the equation 1, 2, and 3. Right. There are a lot of ways to do this. The first thing we see that this is the system of linear equation. By linear, I mean we just have x, y, or lambda by itself. We will not have x squared, y squared, or lambda x, lambda y, or x y, any combination. Just x by itself, y by itself, and lambda by itself. If we use a calculator to solve this kind of problem, that also works. Or we can also do that by hand. Right. There are a lot of options here. Substitution, elimination. So for the first two equations, we can just substitute. We solve for y and then substitute or eliminate y. Right. In class property, I did elimination. So here I use substitution. Right. Since 2x minus lambda equal to 0, if we add lambda on both sides, we'll have 2x equal to a lambda, and here same thing, 2y equal to a lambda. Perhaps I write that again here, it will be better. From equation 1, 2x minus lambda equal to 0, we will have 2x equal to lambda, and if we solve for lambda, it is x over 2. Right. So this will solve for lambda, and we have that. And the second equation, we have the same thing, and if we solve for lambda, we have y over 2. And we'll make them equal. So x over 2 is y over 2, so x equal to y, pretty much. Well, that's one way to do it. So from here we have x equal to y. Right, that is one way to do that. Another way to do that is we solve for x. We solve for x and we solve for y and substitute this equation to find lambda. But as we go along, I'll do different method. But look like we have x equal to y here. I should say both of them equal to lambda, so we make them equal each other. So we have x equal to y. Multiply 2 on both sides. And now if we have x equal to y, we substitute into equation 3. We have negative x. The y we can just use x. And give us negative 2x plus 1 equal to 0. So x equal to 1/2. Since x equal to y and x is 1/2, so is y. So we have xy is 1/2 and 1/2. If we want to find the maximum, the minimum values, we're going to put 1/2 and 1/2 here, and that's what the value says. But the main thing is we're trying to find the point x and y. All right. Now let's use the calculator for this. Yeah. By the way, the problem is done. I'm just now solve the problem using the calculator. Since the calculator on the computer doesn't have that app, I'm going to use this calculator instead. Right. In order to do the equation in calculator, we have to align the variables. So from those three equations, we'll have 2x. There will be no y here for the first equation, and there will be lambda equal to 0. Equation 2, there's no x, but there's 2y minus lambda equal to 0. And then 3, negative x, negative y, and the 1 must be on the other side, so actually it should be negative 1. Right. So that is the system of equation that we're going to solve using the calculator. Right. Sorry. I need to zoom out here. Right. So we're going to hit the app key and we go to that app. We can also use matrix and do reduce row echelon form, but I'm going to do both. Right. If we have this app, just hit enter. We will choose option number 2, simultaneous equation solver. Right. We have 3 variables x, y, and lambda, and 3 unknown. I'm sorry, 3 equations and 3 unknowns x, y, and lambda. Don't need to change much. Hit next. Coefficient 2, 0, negative 1, 0, negative 1, and 0, 0, 2, negative 1, 0, negative 1, negative 1, 0, and negative 1. And then we hit solve. And we have 1/2 and 1/2. Which is of course exactly what we have before. Right. So that we use that app again. Apps, and then go to this, and we'll see using option number 2 for equation. Right. If we use the matrix, will be similar. We will type this in the matrix, 3 rows, 4 columns. So second matrix. By the way, we can use the calculator here. Let's put there for a moment. Good enough. Right. So second matrix, and we're going to put in the matrix. So go to edit, matrix A, and this will have 3 equations, therefore 3 rows and 4 columns. 1 for x, 1 for y, 1 for lambda, and 1 for the constant on the other side. Right. Now we'll just enter 2, 0, negative 1, and 0, 0, 2, negative 1, and 0, negative 1, negative 1, 0. We'll do the reduce row echelon form. Second matrix, go to the second tab and go to option B, I think, wherever it says reduce row echelon form, and we'll apply that to the matrix A, and we have 0.5 and 0.5, which is 1/2 and 1/2 for x and y. Right. Either way, we solve by hand, and even by hand there's a lot of different ways to solve this equation. Right. So that one is that. Right. Now we briefly go to the second problem. Let's see, what do we have? So first, this is the equation, the constraint. We will change that to x plus y minus 8 equal to 0. And that will be the g of xy. Right. Again, those problems usually are very long, so I will divide the page in half. Right, first form the function of x, y, and lambda. So the function is this. The second part of the question is where we Alright. We're back online though. Looks like okay at the moment. I just see some frame drop. Right. Please post on the chat if the stream goes offline. I forgot. Usually it never happened before. Anyway, so what I was saying was on the test there may be two types of questions. The first one is to set up the function of x, y, and lambda, this part. The second part is to solve the system of equation. You will be provided the equation, just need to solve it. So one is up to here, and I need to check something. I have to. Oh, it look like, yeah, it is good now. I didn't see any frame drop at the moment. All right, I'll go back and pay attention on that. All right, we continue. So from here we set up the problem function of x, y, and lambda. From here we take the derivative with respect to x. Will be 2x. That also have x. Will be y is a constant, so will be minus derivative of x is 1, and there will be y, and there will be minus lambda. Those will be the equation that have the terms that have x in it. Then we'll take derivative with respect to y, will be those three terms. 2y squared give us 4y minus xy, derivative of that negative x is a constant, derivative of y is 1, and then minus lambda and then we take derivative with lambda will be just do 3 negative x negative y and negative plus, forgot the lambda here, sorry, minus x minus y plus 8. Alright, equal to 0, equal to 0, equal to 0, and right. Once again, these equations are linear equations. So x, y by itself, lambda by itself. No x square, no y square, no x lambda y, or y lambda. So if we change this equation to a system and we can solve it. So I will put that to x minus y minus lambda equal to 0. Have to align the variable negative x for y minus lambda equal to 0 minus x minus y equal to negative 8. So the x column, y column, lambda column, and the constant on the other side. So again, back on this. Right, second matrix. Edit. I will enter that in 2, negative 1, negative 1, 0, negative 1, 4, negative 1, 0, negative 1, negative 1, 0, negative 8. Right? And then we just do the reduced row echelon form of that matrix. Sorry. I just under the names which we just hit enter. Right. 5, 3, and 7. So we have x is 5, y is 3. Right. Look like the stream is good now. It didn't show any raw frames. Right. If we use the calculator on the test, just gonna write like that. And we have x, y is 5 and 3. Right. Just need to find the point x and y. Sorry, that formula. And also because I'm doing the live stream with the recording, and it shows about 20 seconds later than the actual stream. Right. Right. This equation we won't be able to use the calculator. Right. 3. Right. First we set up the equation. The function minus lambda g of xy and this if we minus 13 have x squared minus plus y squared minus 13 equal to 0. and that will be g of xy. Yeah. Usually I write like that, and we use the arrow to show that this equation will arrive to that equation, and they're not just equal all the way. Right. Now we put in the function for x plus 6y minus lambda times the constraint x squared plus y squared minus 13. By the way, if you have any particular question, please put on the chat. I'm happy to do that. Multiply it out. Right. So that's the setting up part. Next, we'll take the partial derivative. By the way, on the test, there might be a question where you have to take the partial derivative and start from this equation. We might set up the equation, or we start from that equation. Alright, take derivative with respect to x. We have 4, and that have x minus 2 minus lambda times 2x. Let's just write like that. Derivative of x squared is 2x, lambda is a constant. Right, so let's rewrite that as 4 minus 2 lambda x equal to 0. The function with respect to y will be those two terms, 6 minus lambda times 2y. So 6 minus 2 lambda y equal to 0. That's the second equation. The third equation is with respect to lambda. Pretty much you can just copy this equation. Alright, just go from here. Derivative of lambda is 1, so we have negative x squared, negative y squared, plus 13. And so we have those three equations. Right. None of these equations are linear. We have x squared and y squared. That's certainly not linear. Lambda x, lambda y, not linear. We need to have x by itself, y by itself, lambda by itself, and then a number. Right. So in that case, there will be a few options. Either we solve for x in terms of lambda, or lambda in terms of x, or use elimination. I will use elimination here. That's right. So it's not linear, we have to do by hand. Right. So let's take top two equation. Right. What we're trying to eliminate is x and y here. So in order to eliminate the lambda, let's just say eliminate lambda on 1 and 2. So this will have 2 lambda x, this 2 lambda y. So if I multiply just by y on the top and the x at the bottom, better yet, make one of them negative. How about this? In that case, we will have 4y minus 2 lambda xy equal to 0, and the other side will have negative 6x plus 2 lambda xy equal to 0. Now when we add side by side, the lambda to xy will cancel. Xy is not really important, but we will just subtract, just add side by side. Sorry, just add. We try to eliminate lambda. The xy here, we just go with it. So we have 4y minus 6x equal to 0. So from here we can get 4y equal to 6x, or y equal to 6x over 4, or 3x over 2. Right. So that y is equal to 3x over 2. Now we can substitute that into equation 3. This first problem will take a lot of time, but after that, the other problems might not take as much time. Right, we substitute this from what we have earlier into equation 3. Equation 3 is that, so negative x squared will be there. Instead of y, we have 3x over 2 squared plus 13 equal to 0. Now, negative x squared, this one square, so the square will go to every term. 3 squared, x squared, and 2 squared give us 9x squared over 4 plus 13 equal to 0. Now we just need to eliminate the fraction, so I will multiply everything by 4. So multiply everything by 4. So the first term will be negative 4x squared, negative 9x squared because 4 and 4 cancel, and plus 52 equal to 0. I need to zoom out to see the whole problem here. Right. From here it will be easy. Negative 13x squared plus 52 equal to 0. If we solve for x squared, it is going to be equal to 4. And because of that, x equal to plus or minus square root of 4, which is plus or minus 2. Hope you still can see it. Right. Now if x is 2 or negative 2, we're going to put it back in here. We have x, and x is 2, so y is equal to 3. If x equal to negative 2, we do the same thing. So we have the point 2 and 3, and negative 2 and negative 3. Right. There's a problem with this. The original question did not ask us to find the maximum or the minimum, just find the extreme values, meaning if they're both max or min, we need to find both. Right. The only way we can say that it is a maximum or the minimum is just to test them. So at 2 and 3, we just put it back into the function of 4x plus 6y, so 4x is 2, y is 3, and that is 8, 18, 26. At -2, -3. That is give us -26. So obviously this is going to be a max, and that will be a min. So if we have more than one point in the problem, we do need to check. Previous example, there's only one point, and they ask for the maximum or the minimum. Therefore, it has to be the point we're trying to find. If we have more than one, then we have to set up. I have to check the equations. Looking for something. I'll be back in a few seconds. Right, I'm back. So again, if the equation has x squared, y squared, lambda x, lambda y, or xy, we have to do elimination or substitution, meaning we have to do it by hand. Here we use the elimination of lambda, try to get the common terms with opposite sides so we can eliminate. Once we have the relation of x and y, we can substitute into this equation, and pretty much that. Right. I think we did something like this in class number 4, so we're gonna skip that, unless if you want to do that problem, then we will. Right. The next topics is total differential. I will be start with number 5. Right. Those next questions will not be as long. Right. 5. Right. Next, the total differential. I need to zoom back in. Oh, already did. Looks good. All right. If we have z and they ask for dz, so the formula dz is the function with respect to x dx, and plus the function with respect to y dy. And if we have more variable, we just keep stacking to that side. Right. So very straightforward. In this problem, this is the function. Right. So first, we start with the formula. So dz equal to derivative with respect to x. So derivative of this with respect to x, the first term will be -4x. The second one will be derivative of ax is 8, and then y is a constant. We stack to it. Ay squared is a constant with respect to x, so that's all we have. The derivative with respect to x, that part is this, times dx, plus derivative of this with respect to y, that is not y, so constant 0. Derivative of y is 1, so we just have ax as a constant. Ay will be 16y dy. Right. So just partial derivative, and then we stick the dx with derivative with respect to x, and dy to derivative with respect to y, and then we just put in all the values here. Negative 4, x is 1 plus 8 3 dx uh, 1 plus 16 3, and dy is 0.02. It's just a calculator problem. Just put all of that in, and whatever we get is what we get. We have calculator here. So. Right, so open parentheses, negative 4 plus 24, need to turn it on, negative 4 plus 24 times negative 0.01 plus that is 8 and 48. You can almost do this by without a calculator. That's 0.92. So straightforward, pretty much just that. Right. See what we have for 6. Right. We're not finished 6. We'll not do 6 completely. That problem number 6 completely, but this we have w has 3 variables. So in that case, we just have an extra variable. So we can write dw equal to, we still have a function with respect to x, but it has 3 variables now. So we have dx and derivative with respect to y, and dy and with respect to z, dz. And then we just take the partial derivatives. Right, with respect to x first, that would be 12x squared y and 14x z dx. Derivative with respect to y, that's just the first term. Derivative of y is 1, so that's 4x cubed. And with respect to z, just the last term. Derivative of z is 1, so just 7x squared dz. And then we just put all of those numbers in there. Right, that's simple enough. Right. Next is the linear approximation. So we have something like this. Right. Let's look at 7. So linear approximation, the formula very close to that. We will have put it right here. F of xy approximately equal to the function at AB plus derivative with respect to x at AB, x minus a plus fy at AB, y minus b. So the x minus a and y minus b in a sense is dx and dy. Right. So in this case, usually the first thing we do, we look at the problem, and the not so nice number are those. So we say let x equal to 1.02 and y 3.98. So the function is equal to square root of x squared plus y squared. Right. Derivative here is a bit complicated. Right. So that's what we let x and y equal to, or not so nice number, and then we choose a nice number. That close to x is 1 and close to y b. So we choose 4, 1 and 4. Although this problem, the number is not quite as nice. I mean, we should not have to use a calculator to do this kind of problem. Right, anyway, so the approximation, write that again. Approximate, so would be the values at AB plus derivative with respect to x at AB, derivative with respect to y at AB, y minus b. Right. I just need to determine three things: the values of the function, derivative with respect to x, derivative with respect to y. Now originally the function is square root of x squared plus y squared, or x squared plus y squared to the 1/2. If we evaluate at 1 and 4, so it will be just 1 plus 1 squared plus 4 squared to the 1/2, or square root of 17 if you, so 17 to the 1/2, or square root of 17, but we keep the 1/2 power, so it is easier to take derivative. Right. Derivative will not be, by the way, this will be 17 to the 1/2. Derivative will not be as friendly. I will copy the function again. This we have to use the chain rule. So derivative with respect to x is derivative of this box is 1/2. Negative 1/2, sorry. Take the power down, original power minus 1. And then derivative of this with respect to x, that will be 2x. 2 and 2 cancel out. We have x over u to the 1/2. So x u, I mean u to negative 1/2 to bring it down becomes u to the 1/2. U is that. Alright. We just need to evaluate at 1 and 4. So we have 1, so 1 over 17 to the 1/2. And then similarly, we can find the derivative with respect to y, pretty much because the function is square root of x squared and y squared. So with respect to y, instead of x on the top, we're going to have y on the top, and we do the same thing at 1 and 4. Don't worry, this next problem doesn't take as much time, as much space, so we can do that. So it will be 4 over 17 to the 1/2 for derivative with respect to y, and then y and x is 1 minus 8, 1.02. For x minus a is 1. Right, we just need to do this. Right, 17 to the 1/2. This type 0.5 plus 1 divided by 17 to the 1/2. And then 1.02 minus 1. That's silly, but it's just 0.2. 0.02. And then plus 4 divided by 17 to the 1/2. And then 3.9a minus 4. Now we have 4.108 something. Sorry, wrong one. 1.4.1, sorry, what was that? 0.86. Right. On the test, that's as much as we go. We just need to approximate the values of the function. So there's no need to find the actual values and compare. That will be good enough. Right, so the function derivative with respect to x, with respect to y, and then x minus a, y minus b. Right. Next one, 8. Let x be this number. This is more like the actual, because I just want to test the concept, and this is something a lot more doable than derivative. Will get a little bit complicated on this problem. Right, the function because of that will be just x e to the y. Right, and then we choose some nice values that is close to this, and the calculation is simple. Will be b. A is 1 and b is 0. Right, I will write out what we need first. the values of the function. Right. That is the function. If we evaluate at 1 and 0, e to the 0 power is 1, so this is just 1, so this is equal to 1. We take the derivative with respect to x. I guess we have to write down here. Derivative with respect to x will be just 1 and e to the y. Now we evaluate at 1 and 0. F of 1 and 0 equal to just e to the 0 power, so that also 1. And derivative with respect to y e to the y, still e to the y. So at 1 and 0, we have 1 e to 0, so it's still 1. So all of this are 1. Now we just have the x minus a. X is 0.97 minus a, and y 0.02 minus 0. So we have 1 plus that negative 0.03 plus 0.02. So that will be a negative 0.99. I mean positive. Right. So the values of the function, derivative with respect to x, derivative with respect to y, with respect to x times x minus 8, with respect to y, y minus b, and then just find all the missing values. In original function, derivative with respect to x, derivative with respect to y. Right. So that is 8. Next we go to integration, double integrals, that is. Right. I might not do most of the problem, but at least the setting up part. Alright, we take a look at 9 and 10 at the same time and try to see the difference of the two. So first, the same thing that those two integral has, or those two integral have, is that they have the constant limits. And the second part, we check to see if this is the function is separable. So the constant limit, so that easily checked. This function is not separable, where we have x plus y or x minus y, something like that. It's not going to work, meaning we have to do that by hand. This, however, we might work around that. So first, I will rewrite the problem with the proper limit. The limit for x will be the inside. We go from 0 to 2. So inside, we have x, so 0 to 2. On the outside is limit for y, go 0 to 3. Right. Now, this function clearly we have the constant limit. And the function is separable or not will be determined. This one we know for sure is not. Right. What we can do with this function is we just factor out the y, and now we just have a function of x and a function of y. So this is separable, meaning that we can use the Forbinian theorems on this. Let's do this one first. It looks easy. Now instead of that function, we use that function. And then Forbinian theorem says we just group all the x together, all the y together, and evaluate the single integrals. Right. The x first. We have dx. Inside, we go with that limit and the function of x. And then the y on the outside. With the function of y. Now put things together. We have 0 to 2, x to the 4 plus 1 dx, and 0 to 3 y dy. So all the x together, all the y together, and each individual one we can do it by hand or by the calculator. This should be quick, so we just do it by hand. Well, that will be fast enough. Right, with respect to x, integral will be x to the 5th over 5 plus x. Go from 0 to 2. And the other one, y squared over 2, 0 to 3. Then we continue. Put 2 in here, we have 2 to the 5th over 5 plus 2. And put in 0, we have nothing. 0 plus 0. So pretty much just this. And then the other one for y, put in 3, we have 3 squared over 2. And put in 0, we have nothing. So pretty much that's what we have. Alright, so that is 232 over 5 and 9 over 2. Alright. Just use the calculator on this one. 32 divided by 5 times 9/2. I have 144 over 5. Or maybe, sorry, where's the 2? Right, 189 over 5. Of course, on the test you can just use the calculator to evaluate each one of them, multiply, and you should have that. Right. So that is where the function is separable. We just separate the x and y. Number 9, it is not separable. We have to do that by hand. I forgot the plus 2 here. Right, now we go to 9 first. Not separable, so we have to do this by hand. First, take a look inside. Now the only variable here is x, so outside is still 0 to 5. And dy. Now derivative with respect to x, we have x squared over 2, and y is the constant with respect to x, so derivative of a constant, we'll just take an x to it. Right. A few things. That is a constant with respect to x. So derivative of a constant is kx, right? So that's why we have multiplied by x. 3y is a constant times x. Right. Now, notice inside x, so the values here is actually x and x. So we're going to substitute into this x and this x. So I have first put 6 3 square over 2 minus 3 y times 3 for x, and then minus where we put 0 in for x. That is 0. Kind of like this one where we put in 0, we have 0. Alright, simplify this. 0 to 5, and that is 6 and 2 cancel. We have 3, 3 and 3, so that's 27 minus 9y dy. So from this one, as mentioned before, for the single integral, we just evaluate the integral. Right. Math option number 9, from 0 to 5, 27 minus 9y. Don't really have y, so we just use x. The variable doesn't really matter. 22 over 5, fraction 45 over 2. So if you use the calculator on the test, just indicate that like this. Right. So on those two problems, let me zoom out again. One is separable and one is not separable. The one that is not separable, we have to do that by hand from the inside. The one that is separable, we use the Forbidden theorem, collect all the x, collect all the y, and we have two single integrals. And single integrals, you can use the calculator. Right. 11 and 12, kind of the same idea. The function is not, we have a function here instead of a constant. So on the first one, it fails already. We're not going to use Forbidden theorem, definitely. Right. So, by the way, let's denote that clearly. we put the dy inside, so this is going to be y equal to x squared and y equal to 0. So we go from y equal to 0 to y equal to x squared. I copy it for no reason, sorry. Right, now just our last one will be inside and out, where y is the variable. So we'll have 0 and 2. Integral x squared. Since we take the integrate with respect to y, that is the this is a constant. With respect to y, so we'll have an integral of a constant. It's just that constant plus times y plus c. Right. So instead of that, the constant here is x squared. We're going to have y next to it, just like this, a constant times y. Right. Y squared with respect to y, integral will be y cubed over 3. Now we go from 0, y equal to 0, to y equal to x squared dx. Right. Now we're going to substitute in for y. Right. So we have x squared, y will be just x squared, and x squared to the y cube, so x squared and cube. So we substitute x squared in for for y at first. And then we put in 0 for y. This will just have 0. And simplify this. And we have x to the 6. The power to the power, we multiply them, dx. Now we have the single integral. You can use the calculator or just do it by hand. The power rule is simple enough, so I'm not going to do that. I'll let you finish. So for the double integral, we have to be very careful with the variable. Which one is the variable? In this case, y is the variable, x is a constant, and the limit from the inside dy, so both of them are y. Right. So I want to set up the next one as well. Right. This one, even though the function is x squared, but the limits are not constant, so the Forbidden theorem out of the window, cannot use that at all. Now take a look inside. We will have y inside. Right. Just use different colors so it's easier to see. This is y, so will be y equal to 0 to y equal to square root of 4x. And the variable x squared dy. Right. It's not too bad. Now, with respect to y, x squared is just a constant. So if it is a constant, we will just stick the variable y to it. I should keep this. But right now, put square root of 4x into y. And then minus where we put 0 in it. So that will be x squared times square root of 4, actually just 2, square root of x dx. We just simplify 2 x squared, square root of x is x to the 1/2 dx. So that pretty much 2x to the 2 plus 1/2 is 5/2 dx. And integrate 2x to the 7/2 over 7/2. Go from 0 to 4. Right. Multiply reciprocal. So we have 4 over 7, x to the 7/2, 0 to 4. And you can just finish the problem off. Put 4 in and put 0. That should be easy. Right. So that is the double integral. What more important here is the setup. I know we did this in class, but here we'll go a little more details. Right, now I'll try to draw it. Right, x equal to 0, that is the y-axis. We cannot put this in the calculator. The calculator only can do y equal to. So x equal to 0 is that line. Y equal to 2x. I say it. Let's put some scale to this. So that's about 1/2. And y equal to 6. 1, 2, 3, 4, 5, 6. Obviously, we're talking about this region. Right. So to set this up, I'm going to do both. Of course, when we set it up, we have to choose either we're going to have dx dy or going to be dy dx. So if I put dy inside and then dx on the outside, the function in the middle doesn't really matter. In this problem, we don't worry about that. We just worry about the limits. Right. Because we put the y inside, this will be bounded by 2 functions of y. and the outside will be bounded by two values of x. So those are constant. The outside must be constant. Inside, it could be anything. Right. Now we put the dy inside, so we will look in the y direction, the y-axis. First, we see the blue line y equal to 2x, and then we see the line y equal to 6. So meaning we see this first and then that, if we look in that direction. And then on the outside will be just two values for x, must be a constant though. So if we find it, because y equal to 2x, when y equal to 6, x equal to 3, so the values will go from 0 to 3 for x. So that is if we set up dy over dy and then dx. Now if we want to, we can set up dx over dy, dx and then dy, sorry, dx first and then dy. Here we have the function of x, on the outside a constant value for y. Right. Now on the x, we will look in the x direction. The first thing we see is this line. The second we see is that blue line. So we go with x equal to 0 first, and then that line. Since y equal to 2x, we can also say x equal to y over 2. And then two constant values for y, 0 and 6. The outside always constant. Right. So we can set up either dx dy, dy dx. Right. I think we did 14 in class, but I just want to go over a little more details. So the question is always, do we set up dx dy or do we set up dy dx? So let's just, of course here we have two functions for y, so obviously it will be dy dx. That's the y choice. But if we put dx and dy, meaning we're going to put dx inside, I'll tell you what will happen. We look in that direction. Over here we see this line first and then that line. But here we have this curve and then that line. So there is inconsistency here. Over here we have between this function and the line. Over there we have between the curve and the line. For inconsistency like this is a big no-no, because we can only set up two functions. One for the top consistently, one from the left and one on the right have to be consistent. Here we have two functions on the left, so this will not work. So it have to be the other way around, where we put the y inside. If we look in the y direction, first we see this and then we see the curve. This line we don't really see, it's just a straight line, we don't see a function. So we look in that direction and we see this line first and then the curve. On the outside it's just a constant, x equal to 0 and x equal to 8 on the possible x values. Right. A little more details than the one we did in class. Right. Now on 15, just for that for a moment. Right. Let's see if we put the x inside, what will happen. Right. If I put the x inside and dy on the outside, right. Inside, look along the x-axis. First we'll see this line which is y equal to 0. I'm sorry, dx first, meaning we look in the x direction. First we'll see this line, I mean the curve, and then we see this line, which is x equal to 5. So we go from x equal to the curve, and then x equal to 5. By the way, that should be the choice usually if we have the function of x. That's what we go with. On the outside, the y values look like we go from 0 to 5. Right. Now I try to put the y in the middle and see if we can do that or not. Right. If the y in the middle, we need two functions for y. And then x on the outside are two numbers. Right. Now we do look in the y direction. First we see the line y equal to 0, so that's good. So we have one boundary on the bottom, one boundary on the top. The only thing that we have to change is this is y equal to. So if x equal to y squared over 5, we have 5x equal to y squared, and to take the square root on both sides, that's plus or minus 5x and y. Right. Since the y take only the positive values, so we choose the positive, and we're going to put 5x there. And either of this integral would give the same values. You can verify, do them both. We should get the same thing. Right. In fact, we should always try to look at in both ways like this. Actually, I think it's better to go to 18 first. This will reverse the order of integration. Alright, so this is dx dy, so somehow we will turn this to a dy dx. The function in the middle cannot be changed. We go to dy and dx. Because we put y in the middle, dy in the middle, this should be y equal to and y equal to. And then outside just x constant. Right. Now in order to do that, we have to have the region. So first we look at this. Inside, first is y, 10y, dx. So we have x equal to and x equal to. So x equal to 100. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's say 10 is 100. So we have x equal 100. And then x equal to y squared. Just like y equal to x squared, but it's a curve. Right. So this is x equal to y squared. And we go from y0 to 10. Y equal to 0 is here. And because x equal to y squared, if y equal to 10, y will be equal to, if y is 10, x is 100. So this is 10 for y. And we're only talking about the region when y equal to 0 to y equal to 1 to 10. So we only talk about this. not the bottom part. Y equal to 0 and y equal to 10, so only between those. This point is when x equal to 100, when y equal to 10. Right? Now we switch and we put dy inside. If dy inside, we will look in the y direction. We ignore this now because we only look at this region here. First we will see this line, and then we see that curve. So the first line is y equal to 0. Next, x equal to y squared. So we take square root on both sides, plus or minus, of course. And again, this part y is above the x-axis, so it's positive. So we just have y equal to square root of x. And then on the outside, the limit for x, we're just going to choose. For x, it goes from 0 to this point, 100. So that's where we change the order of integration from xy to yx. The function in the middle is unchanged. Alright, so that is 18. Now 17, a little more difficult. First, the dy inside, so this will be y equal to 0 and y equal to ln of x. Y equal to 0 is this line. And y equal to ln of x is this curve. X go from 1 to 10, so I say 1 here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're talking about this region here. Right, originally it is dy dx. Now we will change to dx dy. The function in the middle doesn't do affect the limits. Right. First, now if we look, by the way, we should write the function y equal to ln of x. Right. Now if we look in the x direction of the x-axis, first we see this curve, and then we see this line. Right. Since we put the x inside, we have two values, two functions for x, and on the outside, two constants for y. So we're going to put two functions here. First we see this curve, and then we see this line. It is easy. This line is x equal to 10. So we're going to put 10 on the top like that. Now this y equal to ln of x, we have to solve for x in terms of y. So what we do is we interchange. If we take power of e on both sides, ln and e cancel out, so we have x equal to e to the y. So that's what we're going to put. So since if we change to dx, we have to have two functions for x inside and two values for y on the outside. Now this, we know the y values, it goes from 0, and whatever the y values here is. Since y equal ln of x and x equal to 10, so this values must be ln of 10. And that's what we have. So y equal to ln of 10 and go from 0 to 10. Usually when we draw the limit, we don't really need to specify y and x. We just say 0, ln of 10, and e to the y. and 10 ax dx dy. So be just like that. I leave you number 16 for you. That will be simple enough. That's just a line. Those when we have the curve will be a little more complicated. Right. I think that will be enough. That will be everything that we need to cover for the test. On Monday, we'll go over some of this, and then we go to the new chapter. The new chapter will not be on this test, but will be on the next test. So pretty much all the material needed for the test we cover today. I did not have any question on the chat, either the homework or the lab. So that's why I just keep rolling with these numbers. Anyway, I think that will be good enough for the review. I hope it helped, and as always, thanks for watching.